All right, so now we want to talk about some case studies as far as how to utilize some of these tools and how we implement some of these forecasting methods that we've gone over. So we've got 4 case studies for you here that we want to walk you.
So we're going to start with July 31st, 2021, which was a high threat day over a wide swath of southeast Colorado, and a general moderate threat over the higher terrain along and west of the Continental Divide. And this was a day marked by essentially ample moisture with 1.2 to 1.5 inches of precipitable water, which is basically near the record values for that time of year. So we had actually fairly limited instability, but that was easily overcome by the fact that there was so much moisture available. And so clouds were producing what's called warm layer type rainfall, which is very effective. It's actually the primary cause of the Boulder 2013 flooding events. So our guidance for that day looked very aggressive, with a greater than 50% chance of exceeding 2 inches in 3 hours over a big chunk of the Southeast Plains, primarily over the Arkansas River Basin. And so that easily warranted the high threat, combined with some of the other factors. And the interesting thing about this threat was it was over a wide range of durations, from the 1 hour to as long as the 6 hour duration for heavy rainfall. And then if we actually looked at what happened, all the points that you see overlaid on the threat are qualifying heavy rainfall observations. And on this particular day, there were quite a few amounts estimated at over 5 inches by radar estimated products, and actual observations, I believe, approaching 5 inches over numerous spots in the wet mountains and the Southeast Plains. And there was an actual a riverine minor flood wave on the Arkansas River that started downstream of Pueblo and then moved eastwards. So this was a fairly high threat day that verified over eastern Colorado, but you can see that it actually did not verify over western Colorado, because the ingredients did not come together as anticipated, and more kind of spotty, lighter to moderate intensity rainfall resulted. So now we're going to step through to the next day, which is July 23rd, 2020.
Yeah, so July 23rd, 2020, as you can see, are kind of evolution of QPF guidance. This is kind of from our older version. So we woke up to a lot of monsoon moisture over the state. PW at Grand Junction was 1.01 inches, which is very, very high, with values likely exceeding that further south, closer towards the moisture source. We also had very slow steering flows under a classic summer ridging pattern. So that just meant that storms can drop a lot of rainfall as they're moving slower and very efficiently. So this was more of a 1 to 2 hour threat. So how we kind of drew that threat that day was focused around the higher elevations of southern and western Colorado, as well as the central and southern mountains, with it kind of spilling over a little bit to the southern Front Range and southeast mountains. So this was a low threat. The reason it wasn't higher was that there was some cloud cover that was lingering throughout the morning hours, which just wouldn't allow enough instability to build to perhaps create a lot of widespread convection. So this is what the low threat looked like. In reality, what ended up happening was this really incredible rainfall event over Yuma County. So what we had was the low-level jet kick-in, which is a feature over the plains and lower elevations. And that can help provide lift, and it helped create this MCS with embedded convection. So it actually had a vorticity circulation within itself, and lots of back building with outflow boundaries, just meaning every time there would be a wind gust that came out from the storm, more storms would develop on top of it. So this was a really high moisture environment as well. 10 inches actually ended up falling in southwest Nebraska, which created massive riverine flooding. 6.3 inches fell in Ray from 8 p.m. to 1 a.m., which is about 100 to 200 year average recurrence interval, or about a 1% annual exceedance, so 1% chance of happening every year. So this created a couple days of riverine flooding. So it's one of those events that's not very well captured by models quite yet, especially earlier with more lead time. So earlier in the morning, the models weren't quite picking this up. So this is something that we obviously learn from and try to add into our guidance each year for improvements. And it wasn't even a flood day over Southwest Colorado due to that ongoing cloud cover.
Okay, our next event is going to be September 1st, 2021, which is kind of on the tail end of monsoon season. But nonetheless, Grand Junction had a precipitable water value of 1.1 inches that day, which is well above normal for early September. But the interesting thing is there was a strong moisture gradient in place, so that on the other side of the Continental Divide, Denver's precipitable water was only 0.73 inches. And keep in mind that 1 inch is kind of what we look for precipitable water as a threshold between moderate and higher intensity events. So our guidance that morning showed a pretty large swath of moderate to heavy rainfall potential, but in this case, it wasn't so much the 1 hour rainfall intensity threat that was driving our concern. It was more of the 3 hour duration, because there were faster steering flows, which means that storms would not really, a given storm core would not dump rainfall at a particular location. But the fact that the storms could train or rebuild over top of each other meant that there could be a couple hours worth of moderate to heavy rainfall. So that was really driving the overall threat today. We had something like up to 2 inches in 3 hours of intensity, which is definitely noteworthy for Western Colorado. The other tricky thing from the forecast standpoint was that there was fairly widespread cloud cover due to a vigorous disturbance located further southwest that was moving into the region. So the instability was somewhat into question, which again was what was limiting that 1 hour heavy rainfall threat in favor of the, let's say, 3 hour duration. So nonetheless, when in consideration, all the factors together warranted a moderate threat over parts of southwest and western Colorado, while eastern Colorado did not have a threat that day because of that lower moisture. And on the outcome on this particular day was actually there was plenty of rainfall to be had, widespread light to moderate rainfall, but those intensities never got to the intensities that we anticipated. And so this day went down as a bust for us, so essentially a false alarm, because the rainfall of 1 to 1.5 inches was spread out over enough hours that it didn't really ever amount to a legitimate flood threat. So false alarms are something that we have to deal with. And what we try to do is learn from them and incorporate those the things that we learn into future forecasts.
Yeah, so this was another day with monsoon moisture over the state, but what was really interesting is there was really high surface moisture. So there was dew points in the upper 50s for eastern Colorado and back into the 50s west, which is very, very high. We were also looking at the potential for training storms and moisture convergence along the Palmer Ridge, where there's higher impervious areas, which increase your flood threat. So shown here is the max precip. So it's the maximum precip put out by all of the models going into our ensemble. So you can see some pretty high totals between about 1.5 and 2.25 inches. One other thing that we were also worried about was outflow boundaries. So in a moisture rich environment, if a storm pushes out an outflow boundary, it can easily initiate other storms. So it's a triggering mechanism for lift. So we kind of went with this large area for a low threat, and then really focused on the Palmer Ridge and impervious areas, as well as the foothills for the moderate threat. So this again is just a little bit of know-how about climatology of the hot rainfall spots, as well as knowing kind of where your impervious areas are, where there's going to be increased runoff and potential flooding impacts in higher population areas. So there's 1.97 inches in an hour, or 2.91 inches total over Parker, which is about a 2% annual exceedance probability. So it was significant, but relative to some of the larger storms over Denver, it wasn't as high. But you did get a nice 250 CFS spike at midnight at Cherry Creek near Parker. And so it's always very interesting to see these heavy rainfall events and then the delay and riverine response. So yeah, this was another example of how we take into account higher population areas and impervious areas when we're going ahead and drawing our threats.